Okay, this is going to be a continuation of the last packet tracer exercise we were doing. Though we did not get to it, that's what we're going to be doing today. We will be finishing the packet tracer and using the information that I was giving you in on this sheet to actually fill in and apply them to the networks or subnets themselves. Now, I'm also going to explain the completion rate and how to check results and why this is tricky and why their terminology and how they like to put their terms in here that can get slightly confusing, and why I did it two different ways as well. After that, we'll run through and make sure it works, and it should give you a better idea of subnetting, subnet masking, the basics of that, and splitting up networks, and a few other odds and ends as well as how to do the packet tracer activities themselves. So let's begin. Excuse me. So, if you remember right, I read through all this, so I don't really need to read through this. We have your address block. We have 3 different subnets technically that require different amount of hosts, but we came to the conclusion that this will end up at 32, this will end up at 32, and technically this would be 2 hosts, or 4 hosts technically, 1 network, 1 broadcast, 2 hosts. And basically, make this a little bit bigger for you guys. There you go. So, the one thing that we need to do, I already went through all of this, but I want to start reading in this general region, and again, I don't quite remember if I went through this, but let's go through it one more time. It says to assign the second subnet to the network attached to R1. So, network attached to R1 is here, so that's this guy. That's one subnet. That's the second subnet we're using. The third one is between R1 and R2. That's a serial connection or a point-to-point. Assign the fourth subnet to the network attached to R2, which is at the end of this guy. But what doesn't make sense with this is there's only 3 subnets. So where does a fourth subnet come in? Well, the answer to that is why I've used 2 different scenarios. I just hit the wrong program, so give me a moment. Go away, please. Oh my goodness, go away. Thank you. Moving on. That is why there's 2 different scenarios here. Again, we have the first scenario and the way that you should be doing it, so you use the least amount of addresses to save space. The other way that they want to do is they want you to break it up into same size blocks of 32 hosts or /28 and go from there. So we're going to be applying these addresses down here. These are just for show, and I can run past it just for an example real quickly. It won't take long, but we'll go to that in one moment. What I want to do is I actually want to show you one other thing. So you have your completion rate on the right hand side, and it's a percentage. If you hit check results, it says this is incomplete, please try again. You go to your assessment item tab, and if you notice PC1, PC2, R1 and R2. These are all your different devices that are inside of this logical network technically. And these are all the parameters that you have to fulfill: status, points, which it's points, and then the components, if it's IP or if it's a physical. And this kind of works on maybe like the OSI model will make a statement, but if it's correct and it has a check mark, green check mark, then the percentage is going to go up. But you have to do all of these to finish to get 100%. And you can go back to this and see what you're missing, which makes it extremely helpful. So let's get into the bread and butter of this. So let's just start right where it on the task 2, because we already finished task 1. We've already understood where we're at, and we made our subnets right here. And to explain real quick, the PC2 LAN, remember both of these are going to be 32. So PC2 LAN and PC1 LAN, I started, this was the 30 hosts needed, this was the 15. I started with the bigger one, even though they were both 32, just at habit. Let's say this was 64, this would be on top. If this was 32, this would be in the second one, and then this is 30, which is 4 hosts technically. Again, we can look at the masking on the other side, the calculations, but at the moment I'm really not going to run through that at the moment. I'll do that as we're doing it in the packet tracer. But if you notice, you have a network address, usable hosts, first and last, broadcast address, and subnet mask. So these are all in a nice little rows, and I like to do this so I can keep track of everything. So if we go through this real quickly, you start with the block itself, move on, you would add 1 for the first usable host address of that subnet. Then this is the last usable subnet, usable host address basically. And then this is your broadcast. And the way that you get this technically is you have 32 hosts or 32 addresses you can use within here. If you count, you're actually using logically 32 addresses right here. So 1, 2, that should be, and then 31, 32 logically. Even though it's listed in the base 10, it's actually listed as 31, it's actually logically 32. So I'll just point to this because this is 32. Then it goes up again by 1, then up by 1, up by 30, and then finally up by 1, up by 1, up by 1, up by 1. So right here, this is the 4 usable hosts. So basically in this region, and that's why I'm going to come down here to this now. So the way that I have this laid out is you start with your block address. You add 1 to that on the end where the host is. To get your last usable host address, you take the network address, which is this guy. You do plus 32 to that, so whatever amount of hosts. So it's 32 address plus host. Let's see if I can bring this back. It's close enough. Plus hosts minus 2. So remember 1, which is 1. So 32 minus 2 is going to be 30. And again, there's different ways of doing this. This is just the way that I like to do it. And then finally add 1 again. So you have 31. Then add 1 to get to your next network address. Now you do the whole thing over again, and 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 over again. These are all 32. So you're going to end up with the entire address block right here. The other thing to point out is you have even for these, odds for these, at the end for the host, evens and odds. Again, all to do with the host. We're not really touching the network. They're all going to stay the same. And then we all have /27s, which if we look at one of our sheets real quickly, I'm actually going to use the other one this time, if I can make it bigger for you guys. So a /27 is 32 hosts. Here is your network up to there, and that is your hosts. And then finally, these are all used for network, and then these are used for your hosts, which ends up being 224. So 128 plus 64 plus 32 equals 224, and the rest are usable with the hosts. Okay, and then for that /30, it's all the way down. Here, there's 4. There's your 2 bits that you can use. So that gives you your 4. And if we count all these up, it comes out to 252. Now, I've memorized all these, but it takes a while. That's why I can write this down in a dump sheet so quickly. But that's completely up to you on how you want to handle it. I simply just want to show you some shortcuts on what has worked for me and possibly other students, and what I've shown other students, and it has seemed to work for them also. So I'm thinking it's a good system, but sometimes I could be wrong. Everybody has their own way. Okay, moving on. So let's actually knock this out now. Using our actual... And I have to shrink all this so we can actually use this correctly. And we'll continue. I'll leave a little bit so I can keep clicking back and forth in the background. But okay. So remember, we're actually using 2, 3, and 4, the 4th subnet, not even the first one, because they want to see if you are actually planning this out correctly. Not necessarily that you started in the right place, because if you didn't start in the right place, this all wouldn't be correct anyway. So they want to pull from oddball spots to see if you're correct, and it kind of throws you for a loop. It's more of a learning experience. In real life, you would be stating this as subnet for like class, like a classroom, subnet for faculty, classroom, lunchroom, etc., 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 etc. You know, business administration office. You keep naming them. So what we're gonna do here is we're just gonna sit right where the usable host address are. Not gonna really worry about the other ones right now. So let's read the first one. Assign the first valid host address in the second subnet, so second subnet, to LAN on R1, LAN interface R1, so router 1, LAN interface. First, that's 33. So just remember the network for now because it never changes, and then we'll apply the host. So 33 LAN interface R1. LAN interface. This is a WAN, that's your LAN. So let's go to your CLI, enter, enter. So enable config T. So we want to get into interface, FA0/0. Enter. So at this point we're going to apply the IP address to the interface. IP add. I just like to do IP add instead of address because it actually kind of reminds me of like IP add instead of address. It's kind of just a little quirky thing that some of us do. Okay, so the mask was 225. I'm sorry, 255. 224. Sorry, it's just so many 2s and 5s and 4s, and so at that point we've applied the address in the subnet. We hit enter. Now we have to turn the interface on, no shut, and that one is up. And I will exit out of that interface for now. So that applied that here. Now if we look at we've got a completion rate of 15. Let's check our results. And for R1, we've got an IP address on Ethernet 0/0, a port status of up, which is the no shut, and the subnet mask, which was applied during the IP address syntax that we put in, and those are all correct, and we've completed 16%, so 3 out of 19, which is 16%. Let's move on. Okay, so now we have an idea of exactly what they want us to do. So let's not keep checking. Let's just fly through this and give you an idea of the rest of what we're doing. Okay, so the next one is assign the last valid host address to second subnet. So we're in the second subnet. For PC1, we know that PC1 is in the same subnet, which is connected to R1. So we're going to be the last. They like to do first and last so they know you have a range. So 62. PC1, so same subnet. Desktop, IP config, 192.168.1.62? Now, when you hit tab, it's going to automatically put you in whatever the first octet of classful it's going to be. We want to just put 224.192.168. Now, remember, we're in the subnet, so to get out of the subnet to the next one, we want to put the address we put here, which was 33. So that points the computer towards this interface within this subnet. So last valid host address, first valid host address, we're still in the same subnet, default gateway, and that should be good from there. Now if we back out, and we're sitting at 31%. So, moving on. Where am I at? Oh, I need that. There we go. Okay, so we're right at 62. Let's move on to the next one. Assign first valid host address in third subnet. So we're moving down one subnet. First, again, to the WAN on R1. WAN R1. So we're still in the same one. Interface. So remember what your WAN is. It's your serial 000. So interface S0/0/0, boom, IP address 192.168.1. I wish I remembered 65. Now the subnet mask 225.225.225.224, which never changes. Enter. Now turn the interface on, no shut. And it's going to say it's down because the other side of the interface is not up. And then this is the DCE side, labeled as DCE. So that basically means that you need a clock rate. You always need a clock rate on the DCE side. And Cisco states clock rate. You simply type clock rate. Should be 64,000. There's a bunch of them, and I don't quite know. I think you could do quite a few of them. But that's just what they state, so I'll just stick with that. I really read into it, honestly. So I'm going to exit out of the interface. So we're done with R1 because there's only 2 connections. There's nothing else we need to do. We don't need to name it. We don't need to do any routing protocols for this lab. We don't need to do any security, or we don't need to do anything in that general region. So we're done with this router. We're also done with the PC, and the switch doesn't need to be programmed because the switch is on layer 2 while the routers are on layer 3, so they work on a higher level. So we have the next one. Assign the last valid host address in the third subnet, same subnet. So if you're thinking like I am, which you should hopefully at this point, because that's okay, don't be afraid. third subnet. So last valid host address on R2. So R2. So let's get into this one. Remember, enable config T terminal interface S0/0/0. Again, they're using the same interfaces on each one to make it easier. IP address 192.168.1. I forgot again because you know what? I'm just kind of mechanically doing this. 94. Okay, so 94. And I believe copy and paste does not work on this. Just FYI, so if you sat there typing everything up, it won't necessarily work very well. I think there's a way to do it. I can't remember. It has been a minute since I've done that, but I'll get more into that later. No shut, and now we're changed to up. We should get one more should get something else stating, there it is, that the other side has also come up as well. So now you have a connection across. It should be green. Boom. Nailed it. How about that? Magic. So finally, we can go to our next one. Assign first valid host address. So we're on the fourth subnet now. So down here. First, if you notice there's a pattern, it's starting to become obvious, but R2, so again, same router, and for the LAN. So we're looking at 97. So there's your LAN, 97. Exit to get out of that interface, FA 0/0, enter IP address 192.168.1.97 was it? Hey, look at that, I remembered. Okay, clickety click click. 255.255.224. Enter. Oh shut. Now I'm hitting the up arrow to do this quicker, and in the next one I'm just going to be changing, I'm using the up arrow to just modify some previous commands so I can do this even faster, just to show you. Actually I can't do that because I've applied all my IPs in the router. So we'll do that in the next video, but you can kind of get the idea of that. So we're going to minimize that. So making the assumption, I don't even have to read it, the last valid host address being in the same subnet would go to PC2. So 162 and 224. Remember, they all have the same slash format, which is /27, 192.168, 1 dot, whatever the last IP to the router was, that's your default gateway. Exit, exit, and 94%. I broke it. So I made an error somewhere, and we will find out where I did. So let's go find out where I made an error. It's actually a good thing because so my IP address for PC2 is wrong. Okay. Why is it wrong? Because I actually put 62 instead of 26 because I read it backwards. So there you go. There's some interest. That's actually kind of helpful because it shows you why you can use that tool to figure out what you made a mistake. Now when you go back in, you'd eventually find your mistake by pinging and starting to realize what's going on. But this is kind of nice too, 100%. Okay, so they want you to, we've already done all this, they want you to save it. I'm not going to do that, that's another video, I don't want to overdo it. The clock rate has been done to 64,000. We've already configured the PCs, it's at 100%. And they want us to just ping to the gateways between the routers, and that should be it, I believe, and then routers out, I believe, but they don't want you to ping from one side to the other Because, and I'll tell you why, we need a routing protocol, and we don't have one, and they're not going to run through it right now. So I'm going to teach you one last way to check this. Instead of sitting there and typing the ping command, there's a nice little way of doing this. So you have your scenarios down here. If you click this, you can go back and break it. I don't know why this. So ping test, and now we can add new. These are just packets, and you're just simply saying like ping packets. So simple PDU packets, basically they're called. And if you click the beginning or the source and the destination, which is here, you could see that's successful. So I don't even need to ping. That just tells me I have a good connection and they can actually talk to each other. Now I'm going to do the same thing from this PC to this PC. Notice the source and destination of each is working well. And see how that failed because I actually clicked the wrong one, and you don't have, it cannot get there. So let's delete this. I screwed up, but we'll do it real quick in the right way. So when you do this, if you send this to somebody else, they can simply just run this. One's good, so that connection's good. That connection's good. That connection's good. That connection is good. And then finally, just to show you, that connection will fail. You can do that and leave it like this and save it. And the next person that has to open this up can use that to see if you successfully did it. So if there's an instructor or somebody you want to actually show, this would work out well for them. So real quick, that's the end of this at the moment. Isn't much more to recap. Everything's finished on here. We're sitting at 100%. We've gone over the basics, the actual VLSM, which is here. We've gone over the block here of subnets, filling up the entire network or address block with all 8. And real quickly, just FYI, one last little thing is, if we look at here, our networks, if we look at 32 hosts, we have 8 networks. And if we look at that, we have 8 subnets or networks. So in this case, I don't really want to go back through any of more of the subnet masks. We've gone through the addressing schemes and how to do this. We'll be making another video that is more VLSM later on, but this is going to get you started on how to do these and to figure out where to go from there.